Okay, so this is that weird lesson where it's like I don't really know what I'm supposed to be doing, but I want to earn some points because this was an actual like AP free response question at one point in time. So it says, consider this differential equation. Verify that this is a general solution. So if we want to verify that this is a general solution. Oh, sorry, thank you. If we want to verify that that's a general solution, what you want to do is you want to plug that in and you want to show that it works. Okay, there we go. So we're going to plug x over x plus c in where we see the y's there. And then we have to find dy dx, and then we're going to plug that into this side. So first thing I'm going to do is I'm going to find dy dx, because it's something that I'll need. So if we do low d high, it's just x plus c, minus high d low is just x, because c is a constant, and then over the bottom squared. Okay, and then the x's will cancel, so we just get c over x plus c squared. Let me know if I mess something up. Okay, so that's going to end up getting plugged in for this side. So I'm just going to start by writing this so my steps are super clear. So I'm just going to write what's up there. dy dx equals y minus y squared over x. And then I'm just going to move to my next step here. So for dy dx, I'm going to put this in. So I just plugged that in for this side. And then equals. And then instead of y, I'm putting x over x plus c into the y spot. And then instead of y squared, same thing, it's just going to have a squared with it. And it's all over x. And it just says verify, so hopefully we can get it like using algebra so that these two sides look equivalent to each other. So I'm just going to move down here. And I'm going to clean up this right-hand side a bit. This would be, let me just rewrite this as x squared over x plus c squared. So my next step is a little bit more clear. And we're going to pick the common denominator to multiply the top and bottom by. So I'm going to multiply top and bottom by x plus c quantity squared. And we'll see what happens here. So we're going to distribute it through to both sides. So the left side I'm just going to leave as is. Okay, so left side I'm just going to write down c over x plus c squared. And then the right side, if I distribute this through, one of the x plus c's will cancel, right? So that's just going to leave this x here times the other x plus c that didn't get canceled. That makes sense? Okay, and then we distribute it here. And what happens there is the x plus c squareds cancel, so all that's gone, so you just have minus x squared. And I'm starting to see the end of this one now. Okay, so left side, I'm going to leave it alone. And the right side, do you see if I distribute this through? In the numerator, the x squareds are going to cancel. So in the numerator, all I have left is x times c. And in the denominator, all I have left is x times x plus c squared. And then I always like to write it where they look exactly the same, because right now the x's are going to cancel, and then it's just going to be this equals the exact same thing on the other side. So I'm just going to write that right below it here. I don't remember how much room I left in that packet, but you can squeeze stuff wherever. So that's verifying it, check. So I'm done with this part. Verify that that is a general solution. And then the other part to this says, and show that all solutions contain 0, 0. It's like, what? I don't know. So you want to do something with that, even if you have like no idea what to do with that. What we're going to do, this is just saying, show that 0, 0 would work in the equation. So, and verify and show all solutions contain. So it's saying this is a general solution here. So we want to verify that this has 0, 0. So all we're going to do is start with y equals x over x plus c. And we're going to plug in 0, 0. So I'm just going to do that right below it here. So I would get 0 equals 0 over 0 plus c. So we just have 0 equals 0. So I've shown that that works. So those are really the two things. It's just a really weird question because you're like, what did I do? You showed that it worked is all you did, okay?